In this video, let us continue to solve word problems based on simultaneous linear equation. And we've got a problem here which is about traveling. It says Ved travels 600 kilometers to his home partly by train and partly by car. He takes 8 hours if he travels 120 kilometers by train and the rest by car. He takes 20 minutes longer if he travels 200 kilometers by train and the rest by car. So find the speed of the train and the car. All right. So he partly travels by train and car, and then the question is about, the data is the total distance is given 600 kilometers, and how much distance he travels in train and the rest by car. Then he takes 8 hours. Then if he travels 200 kilometers by train and the rest by car, he takes 20 minutes longer. That is 8 hours 20 minutes. So the first thing that we need to know as far as this problem is concerned is, you can see that there is distance and time. So you need to know about the speed, right? So first thing is, speed is distance by time, or time equals distance by speed. You need to know this basic formula to solve this problem. So now we need to assume as far as these problems are concerned. So what is that assumption? The question is, find the speed of the train and the speed of the car. So the first thing is, let the speed of the train, we need to, give some identity to those. Let the speed of the train be something and the speed of the car be something. So now, let the speed of the train be x kilometers per hour. That's how you measure speed. And let the speed of car be equal to y kilometers per hour. Right? So now there is this two case kind of thing. The first one is, if he travels 120 kilometers by train and the rest by car, he takes 8 hours. But if he travels 200 kilometers by train, then the total thing changes, right? So let us come one by one. So the first is, case 1. What is case 1? When he travels 120 kilometers by train and the rest by car. So now if Ved travels 120 kilometers by train, then he travels 600 minus 120 kilometers by car. That is what? 600 minus 120 by car. That is nothing but 480 kilometers by car. Right? So now we need to find the time separately. Like, how much time does he travel in train and how much time does he travel in car? Because we know the total time. So once we find the time, and then, since we've got the distance, all we have to do is find the speed. So now, the time taken to cover 120 kilometers by train is, let us see that. Time taken to cover 120 kilometers by train. As you can see, time is distance by speed. So the distance he travels in train is 120, and the speed of the train, we've taken it as x kilometers per hour. So it will be 120 by x. The time is given in hours, so it's 120 by x hours. So the next thing is, time taken to cover 480 kilometers by car. Now again, time is equals distance by speed. The distance he travels by car is 480. Speed of the car is y. So 480 by y hours is the time that he takes to travel by car. Now, most importantly, it is given that the total time is 8 hours, right? So we found individual time. Time taken to cover so much in train and time taken cover to whatever in car. So add both the times, you need to get 8 hours. So here we've got the first equation, 120 by x plus 480 by y. These both are times. This is the time traveled in train. This is the time traveled in car. If you add them both, you need to get 8 hours. So here we've got the first equation, right? So again, this is not the simultaneous linear equation that we're looking at, because this is only reducible to the form. So let's keep this like that. If we divide throughout by 8, we will get 15 by x plus 60 by y, because 8 goes 15 times in 120, it goes 60 times in 480, and it goes 1 time in 8. So we get equals 1, or we can write it as 15 by x plus 60 by y minus 1 equal to 0. Just get the minus to the left hand side. So this is case 1. Case 1 is over. We found one equation. That's fine. So now the next thing is case 2. Case 2 is what? He travels 200 kilometers by train as opposed to 120 kilometers, and then the rest by car. So once we take case 2, we can straight away find the time taken to cover 200 kilometer by train. The time taken to cover 200 kilometer by train will be equal to distance by speed. So 200 divided by x. This is time by time for train. And then we've got for the car. For the car, it will be 600 minus 200. That will be 400 by y hours. So it will be 200 by x hours and then 400 by y hours. So these are the time taken when he travels, that extra thing. But then the most important thing is it doesn't stay at 8 hours. It becomes 20 minutes longer. So it becomes 8 hours, 20 minutes, right? So in that way, we get 200 by x plus at these times. That should be equal to 8 hours and 20 minutes. Here we are. So 8 hours and 20 minutes can also be written in fraction like this. 20 minutes is what? 1/3 of 60 minutes, because 60 minutes make 1 hour. So 8 1 by 3 is what we can write here. And that becomes, it's a mixed fraction, right? 8 1 by 3. So it's going to be 25 by 3. So this equation is equal to 25 by 3. Now dividing throughout by 25, 25 goes 8 times in 200, so 8 by x, plus 25 goes 16 times in 400, so we get 16 by y. And 25 goes 1 time in 25, so it becomes 1 by 3. So we've got two equations now, this one and this one. Of course, we can write this as 8 by x plus 16 by y minus 1 by 3 equals 0. So let's keep this as equation 1 and let's keep this as equation 2. So now if we solve these two equations, we can get x and y. That's all we have to do, right? So all we have to do is solve these two equations, the equation 1 and equation 2. The equation 1 is 15 by x plus 60 by y minus 1 equals 0. Then the equation 2 is this one. 8 by x plus 16y minus 1 by 3 equals 0. And these two have been formed by using the data given in the question very clearly. So now this is definitely not the simultaneous linear equation. This is of the form that can be reduced to that. We need to substitute 1 by x as u and all those things. So now what we can do is taking equations 1 and 2. Let's take 1 by x is equal to u and 1 by y is equal to v. So therefore we will get 15u. If you substitute in the place of 1 by x u, you will get 15 times u plus 60 times v equals 1. And in this case, you get 8 times u plus 16 times v equal to 1 by 3, something like that. Or 15u plus 60v minus 1 equals 0. And 8u plus 16v minus 1 by 3 equals 0. So now, since we've got a fraction here, we need to change this whole equation. So let us multiply throughout by 3. So this equation will be as it is. Now this will change to, if we multiply throughout by 3, we get 24u plus 48v minus 1 equals 0. So these are the new equations, 3 and 4. Now what we have to do is we need to solve the equations 3 and 4. This sheet is a continuation of the topic word problems based on simultaneous linear equation. Traveling 600 kilometers to his home partly by train and partly by car. And there are some data. We need to find the speed of the train and the car. And the next equation we've got is 24u plus 48v minus 1 equal to 0. So the numbers are quite big for, say, either the substitution or the elimination. What we can do is we can look into cross multiplication method. All that we have to do as far as cross multiplication method is write the variables like this, u, and then negative v, and then the constant number, Then you need to divide it, of course, equate it. So u divided by, leave the coefficients of u, take the rest. So it becomes 60, 48, and minus 1, minus 1. Below the v, leave the coefficients of v, take the rest. So 15, 24, minus 1, minus 1. Below the 1, leave the 1 and take the rest. So it becomes 15, 24, 60, 48. So you need to multiply it like this, like a ribbon, like this. So it becomes u divided by 60 minus 1 is minus 60, and minus of 48 minus 1 is minus 48, equals minus v divided by 15 into minus 1 is minus 15, minus of 24 into minus 1 is minus 24, equals 1 divided by 15 times 48 is 720, minus 24 times 60 is 1440. So the only place where we multiplied something big is this. So continuing, we get minus 60, minus of minus 48 is minus 60 plus 48, which is minus 12. U by minus 12 equals V by minus 15, minus of minus 24 is minus 15 plus 24, which is V by minus 9, equals 1 divided by 720 minus 1140. Well, we get a minus 720. So this is what we've got. So all that we have to do to find u and v is just equate this to this and this to this to find u and v. So we get u divided by minus 12 equals 1 by minus 720. The negatives cancel. We get u equals 12 by 720. So that is 12 goes 60 times in 720. So we get u as 1 by 60. And let's see what we get v. V by minus 9 equals 1 by minus 720. So minus minus gets cancelled. V equals 9 by 720. 9 goes 80 times in 720. So we get v as equal to 1 by 80. So now that we found v and u, the problem hasn't come near its end. Now we have to find x and y using v and u. We know that we've taken u equals 1 by x and v equals 1 by y. So if u is 1 by 60 and we've got 1 equals 1 by x, then x will be equal to 60. And what is x? It is kilometers per hour. So x is 60 kilometers per hour. And we've got v as 1 by 80 will be equal to 1 by y. So y will be equal to 80 kilometers per hour. So we took the speed of the train to be x and the speed of the car to be y. So therefore the speed of the train is found to be 60 kilometers per hour. The speed of the car is found to be 80 kilometers per hour. So this is how we solve this problem. So let me quickly go back to the problem and take you through again quickly. So the whole concept is this guy traveling to his home partly by train and car and then taking some amount of time. When he travels a little longer in train, the time also takes a little longer. So this is the data given and we have to find the speed of the train and the car. So first thing is identify the variables that you have to assign. What is the question here? Mainly speed of the train and speed of the car. So let the speed of the train be x kilometers per hour and let the speed of the car be y kilometers per hour. And in the first case, because he takes 8 hours when he travels 120 kilometers and the rest by car. The second case, he travels a little longer in car, that is 200 kilometers by train and the rest by car. So form equations by that. For that, you need to know this one, time equals distance by speed. So once you know this, it's pretty simple. So then just work out the time taken. You've got these two equations. I think the problem ends as soon as you get this equation, because after that, it's only basics of simultaneous linear equation. So all the most important thing is getting this equation right. Mainly time, realizing that time equals distance by speed. So you've got the distance, you've assumed the speed, so you get some equation and then go on to reduce it to simultaneous linear equation and find x and y. So which ends here when we find the speed of the train to be equal to 60 kilometers per hour and the speed of the car to be equal to 80 kilometers per hour. So this ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on word problems related to simultaneous linear equations.